Let's start by talking about the big picture of a database system. What's its architecture, generally speaking? And then we'll dive into some of the sections over the course of the next very many lectures. So to begin with, think about the architecture of the database being a client and a server, where the SQL is typed in at some client. It could be a web client, it could be an application. But the application is a client, and then there's a database management system, which is a server. So in the last few lectures, we've been looking at SQL, the query language, but what we want to look at next is how is that SQL query executed. So inside the database management system, there are a number of modules. The first module that the SQL query goes to is the query parsing and optimization module. Its job is to parse and check the SQL, verify that it's legal, and then translate it into a relational query plan that the system can execute. And we'll talk about what a relational query plan looks like over time. The relational operators are the actual operators used in a relational query plan. They are the individual algorithms that are put together to execute a data flow. That data flow operates on records and files, pumping data through the operators to generate output answers to your query. Underneath the relational operators, there's a module called Files and Index Management. And its purpose is to organize tables and records as groups of pages in a logical file. You can think of a file like a file on your laptop. And here, the pages of that file are going to hold tables full of records. We'll talk about exactly how that's organized. Beneath the file and index management layer is a buffer management layer. And the buffer management layer provides the illusion that we're operating in RAM, in memory, rather than dealing with disks. So the file and index management logic, the relational logic, all that stuff assumes that stuff is in memory. And the buffer manager's job is to map disk blocks from the disk drive into the memory of your system. And we'll talk about how that works over time. Finally, below the buffer management code, there's disk space management code. There's a module in the database for disk space management, and its job is to translate page requests from the buffer manager into physical bytes on one or more devices, like magnetic disks or solid-state disks. So that's the general architecture of a database management system, and over the course of the next many lectures, we'll go through each of these modules, as well as how they fit together. Notice, though, that at a high level, this whole thing is organized in layers, and each layer is abstracting the layer below. So query parsing and optimization thinks only about the relational operators. It doesn't really worry about the APIs of the layers below that. Similarly, the relational operators worry about the file and index management APIs, but they don't think about the buffer manager or disk space manager APIs, and so on. Each layer is abstracting the layer below, which keeps the complexity of the system at a minimum. So that's a good thing in an architecture of a system that's going to be millions of lines of code big. Across these layers, some assumptions are being made about performance. The optimizer is going to make assumptions about disk speeds, for example. And those assumptions you hope are good enough that they can be reasoned about across these layers, even though they're not explicitly in the API. So relational databases are a great example of good systems design. Remember, these are systems that can grow to be millions of lines of code and that are developed over many years, even a decade. It's common wisdom that it takes about 10 years to mature a really good database engine, and so you can imagine how big and complex these things are. It's important to keep the architecture nice and clean. Now, on the side of this architecture, what we've seen so far on the right is basically a single user architecture, but there's two cross-cutting modules or issues that are related to storage and memory management. One is concurrency control, which is how we allow multiple users to use the database system at the same time without messing up each other's data. And the other is recovery, which is the module that's in charge of making sure that if your database crashes, we can recover your important data and get the database back up and running. So those two modules, concurrency control and recovery, exist sort of to the side of the layered stack that we've seen before and interact with a number of the layers related to storage and memory management. So to give you a little bit of a map of where we are and where we're going, we've already completed our discussion of SQL. And over the next many lectures, we're going to start from the bottom of the database system and work our way back up until we've covered all of these modules for at least single user databases. And after we're done with that, we'll look at concurrency control and recovery. So our next topic is to talk about disk space management, which is what sits at the very bottom of a database management system. Along the way, when we talk about disk space management, we will pop up and briefly talk about files and index management, just to kind of get a taste of some things.